computing, it's all about bits. And each bit is worth 0 or 1. Two values that allow us to encode information. You know, a binary system. And that's how a computer does its number crunching. But such calculations can be done with other objects that exhibit two states of being. For example, atoms. An atom has an excited state and a ground state. Excited, ground. However, an atom belongs to the quantum world and as such obeys very special rules. It can, for example, exhibit both states simultaneously, neither one nor the other, but a mixture of both at the same time. If we had bits like that, we could probably achieve more complicated calculations than with zeros and ones, as if the operations happened in parallel. But there's a little problem. An atom can only behave like that if it's isolated. The slightest interaction makes its quantum properties disappear. Not easy. But here's a lab where they're being studied. In this chamber, physicists have placed atoms from a material called strontium, just a few. To make sure they don't touch their surroundings, they've been made to hover using an electric field. And a laser's been pointed at them to make them fluorescent, you know, so you can see them. And here are the atoms in their two possible states, on or off, excited or ground. And if we can't observe them, if they interact with nothing, then their two states, excited and ground, are in superposition. And that makes them quantum bits. They can even be inserted into small chips like this, similar to computer chips. And perhaps one day, but not just yet, we will be able to perform ultra-fast calculations thanks to quantum chips.